Hey guys, and welcome to section 4.1 called Graphing Polynomial Functions. Now we're going to spend a couple days on this section, so in this video tonight we're just going to get introduced to what a polynomial function is and evaluating polynomial functions. So our first learning target is I can identify a polynomial function and write it in standard form to identify its degree and leading coefficient. All right. Recall that a monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. So a monomial basically means one term. So for instance, it says it could be a number. A monomial could be 2. It could be a variable. A monomial could be the variable a. Or it could be the product of a number and one or more variables with whole number exponents. So I could also have 2a, or I could have 2ab, or I could have 2a cubed b to the fifth. The point of this is all of these examples I've given you are just one term. There's no addition or subtraction sign separating them. And the big thing here is that they have whole number exponents. If you don't remember what whole numbers are, whole numbers start with 0, and then they're all the positive integers. So I'll put that over here as a set. The set of whole numbers starts with the number 0, and then it's all the positive integers after that, going up to positive infinity. So you can't have decimals in the exponents, you can't have negative numbers, you can't have irrational numbers, and stuff like that. Well, if you understand what a monomial is, a polynomial is just a monomial or the sum of monomials, because poly means many. So it could be just one term, a monomial, but it could be many more terms. So we're going to talk about the standard form of a polynomial function of degree n is right here with lots of mathy lingo, right? F of x equals, we have a with the subscript of n times x to the power of n. And then the next term is a with the subscript of n minus 1. That means it's just one less than the previous term. So if the previous term was the fifth term, this would be the fourth term, okay? And then the same thing here. The exponent is n minus 1. So if, again, let's say we started with an exponent, and this is just an example. If we started with an exponent of 6 here, then this one would be 5 because it's 1 less than 6. Now, the point of it is, writing it this way, is that standard form means that your exponents are going from highest to lowest. And if you see at our last term here, it doesn't have any exponents on it, which means it's our constant term, and that would actually be x to the 0. But we don't write that because anything to 0 power is just 1. So I'm going to write some important things on here. Those were just examples, so that's why I'm erasing those. First, it says where a sub n cannot equal 0. So that means obviously we have to have a coefficient on x to the n. Either it's 1 or it's some other number. The exponents are whole numbers, just like we talked with monomials, and the coefficients are real numbers. So this means we're not going to have any imaginary units. And then I've mentioned this a little bit before. Terms must be in order by their exponents, starting with the highest and ending with the lowest. And then all of these terms, once we have them in that order, the degree of the polynomial is the highest exponent, which actually should be your first exponent you see if you wrote this in standard form. And the leading coefficient is the coefficient of the first term when the polynomial is written in standard form. So I've actually identified these two things in our polynomial up above. A sub n right here, that is the leading coefficient. That is the number before your first variable with the highest degree. And so that's the degree of your polynomial. Okay, so let's look at some polynomials that we've talked about before, and then it might become a little more clear. We have talked about linear, quadratic, and cubic functions, and these are all examples of polynomial functions, which are categorized by their degree. So let's look at this table. It definitely helps us clear up anything we might be confused about. If our degree is 0, this is known as a constant function because it would just have your leading coefficient a sub 0, because remember, we're not going to write x to the 0 power because x to the 0 power is just 1. So the example on the right is just f of x equals negative 14x. I'm sorry, not negative 14x. Negative 14x to the 0 would be what this is, but we don't write that. Degree 1 is a linear function because the highest exponent we have on this is the first power. Okay, so example, 5x minus 7. Degree 2 is a quadratic, so we just got done talking about these. Our highest exponent is squared, and then we have exponent to the first, and then we would have that a sub 0 gives us the x to the 0. And so on and so forth. We can see the patterns here. A degree 3 polynomial is called a cubic. We should be familiar with that. A degree 4 is actually called a quartic. And after we reach higher than degree 4, we kind of just categorize them by their degrees. Okay, so this is what our first learning target entails. First, we are going to tell whether each function is a polynomial, and if it is, write it in standard form and identify its degree, type, and leading coefficient. So to determine whether it's a polynomial, we really just have to look at its exponents and make sure all of the exponents are whole numbers. So in letter A, we have f of x equals x cubed plus 4x squared minus x to the fourth plus 1. Now 3, 2, and 4 are definitely all whole numbers, and remember any constant we have is just times x to the 0. And 0 is our smallest whole number, so this one, yes, is a polynomial. So to write it in standard form, we need to put the exponents in order from highest to lowest. So the highest exponent is 4, so we'll have negative x to the fourth. Then we have plus x cubed, then plus 4x squared, then plus 1. So because our highest exponent is 4, that is our degree, which helps us name the type of this function. The degree is 4, so that is a quartic function. And the last thing we identify is the leading coefficient. That's the number in front of our first term, our first variable. It's just a negative sign, which we know is negative 1. So leading coefficient, I just say LC to abbreviate, is negative 1. Okay, moving on to letter B, P of x equals x squared plus 3 to the x. So first to determine if it's a polynomial, we ask ourselves, are both exponents whole numbers? The first one is the number 2, but the second one is the variable x. So this term right here makes this not a polynomial. And that is because there's a variable in the exponent. And we will get to those when we get to exponential functions. All right, let's look at C. F of x equals 4x to the negative first plus 3x squared minus 5. Again, we ask ourselves, are all of its exponents whole numbers? And we should see right away that we have a negative 1. Negative 1 is not a whole number. It's a negative number. In fact, what we could also write this as is 4 times 1 over x. If you remember that negative exponent property, to make it positive, you move it to the bottom. So this makes this a rational function, actually, which we're going to get to in a couple sections. But moral of the story, this is not a polynomial. This up. And that is because there is a negative exponent. All right, let's look at D. K of x equals negative 0.8 x cubed plus the square root of 2 times x to the fourth minus 12. Looking at the exponents, I have 3 and 4, and this exponent, remember, would be 0, all of which are whole numbers. So yes, this is a polynomial function. And let's write it in standard form. Looks like we would put the square root of 2 times x to the 4th first, then minus 0.8x cubed, then minus 12. This one, because our highest exponent is 4, is also a degree 4 function, which is called a quartic. And finally, the leading coefficient is this irrational number, rad 2. All right, that's our first learning target. Our next learning target will be pretty quick. We've done this before. It's evaluating a polynomial function. I can evaluate a polynomial function given an input value. Evaluate the polynomial function with the given x value. So basically, guys, all we're doing is plugging and chugging. We're given a function and we say when x equals some particular value, and we plug it in for x and evaluate. So f of x equals 2x to the 4th minus 8x squared plus 5x minus 7. Evaluate when x equals 3. So that means we're finding f of 3. So I'm going to put 3 in for every x value here. Remember that you can put that entire expression in one expression in your graphing calculator if you would like. But I'm going to go step by step just so you can see that, because I cannot show you my graphing calculator right now. That'd be 2 times 3 to the 4th, and 3 to the 4th is 81. Minus 8 times 3 squared is 9. Plus 5 times 3, that's 15. Minus 7. All right, 2 times 81 is 162. 8 times 9 is 72. And I can take 15 minus 7, and that is 8. 162 minus 72 is 90. Then I add 8, I get 98. So f of 3 equals 98. On to letter B. I have negative 3x cubed minus 7x plus 4. This is a cubic function. We haven't seen one of these yet, with a leading coefficient of negative 3. It's telling us to evaluate this one when x equals negative 1. So f of negative 1 equals negative 3 times negative 1 cubed minus 7 times negative 1 plus 4. Negative 1 cubed is still negative 1, and negative 7 times a negative 1 is a positive 7. Then I have plus 4. This would be 3 plus 7 plus 4 is 11, and so I get 14. So f of negative 1 equals 14. Okay, so I hope you feel pretty confident in evaluating polynomial functions, which is just plugging an x value in. And also, when I give you a function, determining whether it is a polynomial or not. If it is, writing it in standard form, which is basically all of its terms in order from highest exponent to lowest exponent, and then you can identify the degree, the type, and the leading coefficient. All right, I'll see you in class tomorrow.